Special derivatives part 2. Here we go. Let's take a look. This one is simply a weird way of saying take the derivative. So f of x equals secant x plus e to the x. And it's asking what is the rule for f prime of x. And all you're doing is just taking the derivative. So I'll take the derivative. The derivative of secant is, pause it, maybe think of it yourself. What is it? Yes, secant tangent. And the derivative of e to the x, that's the weird one, that is just e to the x. That's all. That's all you do there. That's it. That's it. That's it. The derivative of e to the x is just e to the x. So it's beautiful like that, you know? It's beautiful. It's beautiful. Example 4. All right, suppose that f of x equals 2 times e to the x minus 4x. Find the derivative when you plug in the natural log of 3. All right, this seems a little weird. People will freak out maybe. Don't freak out. It's very simple. So what do we have? Well, let's take the derivative first. Remember, you can pull out constants. If you have derivative operator, you can pull out that constant. So we just have the derivative of e to the x, and then multiply by 2. Well, that's still just 2e to the x, because the derivative of e to the x is e to the x. And then minus the derivative of 4x is just 4. Okay, that's nice. That's very nice. All right. And then, well, what do? We plug in the natural log of 3. So f prime of the natural log of 3, ln of 3, don't say ln, or say ln, I don't care, but it's wrong. So the derivative, when you plug it in, you get 2e to the natural log of 3, that was my stomach, and then, what, minus 4, right? Yeah, that's right, yep. Alright, so properties of logarithms. Maybe I should review this real quick. The bell. Oh, the bell. So, look at this. This is a quick review of logarithms. First of all, you can think of it like this. Log with some kind of base. If you plug in that same base, you get 1. If you have a base, like an exponential base, with the log with the same base, then you can think of it as the logs canceling, or I mean the log and the base canceling out, so you just get whatever's on the inside. And then the natural log is just log base e. So it's no different than that. Okay, so if the natural log is log base e, then what do we have? We got equals to e to the log base e. You don't have to write this out if you already know. But now the e and the log base e cancel out because of that. Oh my goodness. So what is it? It's 2 times 3 minus 4. That's 6 minus 4. And it's just 2. It's just 2. Oh, isn't that beautiful? All right. Cool. All right. Last one. I feel like I'm covering everything. So last one. F of x equals x squared plus cosine of x. Find f prime of x. No, find f prime when you plug in pi over 2. So, what you do here? All right, listen, kid. What you do? You take a derivative, huh? You just take the derivative. Use the power rule. Take the derivative. Okay. So you get f prime of x. That is gonna equal 2x, and then derivative of cosine. That's just the negative sign, right? The negative sign. Okay. So negative sign, it's got a cosine, so it gotta be negative, and it's a negative sign of x. And now what do you gotta do? You plug in pi over 2. Ring a ding ding, ring a bang 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 bang, bing bang boom. All right. So what you get f prime of pi over 2. You just plug it in, and you just get pi over 2 times 2. Oh, look at that! That cancels out. Ain't that beautiful? It's pretty beautiful. All right. The sine of pi over 2. Okay. So what's the sine of pi over 2? Well, let's look at the unit circle, huh? Pi over 2 is this angle right there. So what do you do? What's the sine? It's the y-coordinate. That's the y-coordinate. Y-coordinate is 1. Okay, so we got pi minus 1. That's it. That's the answer. It's simple as that. All right? Get my face.